Have you seen a solar panel? I think you must have, right? So, what it is based on? Solar panel is based on photoelectric effect. What happens in that we are going to study over here. So, in a solar panel, how it is taken as we take a metal sheet, and sunlight falls on the atoms of the metal, and that strikes electron of the atom. Now, electron is bounded to a nucleus. All right. So, electron is bounded to a nucleus, and the energy known as binding energy. Let's say binding energy, and we can call this as work function also. We can call this as work function also. So when light, let's say sunlight, falls on electron, so it has to do what it has to do. Let's see. It what it needs to do is it needs to remove the attraction of nucleus on the electron. If electron is attracted to a nucleus, let's suppose this is nucleus and this is electron. If we hit the electron and the energy we give to electron is greater than the attraction, then it will be removed. If we give energy lesser than the attraction, this binding energy is holding this electron with the nucleus, right? If you give the energy greater than binding energy or work function of the metal, then the electron will be removed. If you give energy lesser than the binding energy, then electron will not be removed. All right. So it is not that all the light will remove the electron. Say in the morning when the dim light is there, or in the evenings, late evenings, when the light is dim, electron is not getting removed. So this electron is again put into the wires, and it goes into the wire, and you get electric current. So electron is falling in the form of photons. You have this light is falling in the form of photons, and photons are falling on electron and removing this electron from the atoms. So electron removed by the fall of photon is falling and it is giving its energy to the electron, and electron is removed. The electron removed by a photon is known as photoelectron. Electron removed by photon is known as photoelectron. When it will be removed, this electron, a minimum energy, the photon should have a minimum energy known as threshold energy. And what it will be? The threshold energy of a photon should be equals to work function of metal. Threshold energy should be equal to work function of metal, and work function of metal could be calculated as h nu naught. Nu naught is the threshold frequency. This is the minimum frequency for which electron will be ejected. All right. So threshold energy equals to work function of metal, and that is equals to h nu naught. Nu naught is the minimum frequency for which electron is ejected. Let's say if work function equals to 5 electron volt of energy, and the falling energy is of 5 electron volt. What do you think? The attraction is of 5 electron volt and the falling energy of 5 electron volt. Then what do you think? The electron will be just removed. It will not gain any kinetic energy. But if we give slightly higher 15 electron volt of energy of the photon is falling, then electron will be removed. 5 electron volt energy will be consumed in breaking this attraction, and 10 electron volt of kinetic energy this electron will have. K max will be 10 electron volt. All right. So the energy of falling photon is used in two tasks. First task is removal of electron, taking the electron away from the attraction, and the remaining part is given in the form of kinetic energy. As I have taken example, 15 electron volt of photon is falling. Work function of the metal is 5 electron volt. Then 5 electron volt out of 15 is used in breaking it away, and the remaining 10 electron volt energy is the kinetic energy of moving electron. And this moving electron is also known as photoelectron. Now, some basic points in photoelectric effect are like this. Firstly, higher the light falling, higher the intensity of light falling, higher will be the rate of emission of electrons, right? So more will be the current we get. So it is always known that in summers you get high intensity of sunlight falling on the panels, so you get greater good current because electrons ejected are more. Whereas in rainy season you have less light falling, so you have less current. In winters also some less current is generated. All right, few more points are there, as in if energy or frequency of falling light is more, then kinetic energy of ejected electrons will be more because work function is a constant value. So higher the falling light energy, more will be the kinetic energy of incident, more will be the kinetic energy of photoelectrons. All right, and some three cases we have discussed over here. If frequency is lesser than threshold frequency, we are calling it as threshold frequency, or you can call it as critical frequency, the same value, that minimum frequency for which ejection is happening. So if falling light has a frequency lesser than threshold, no ejection of electrons. If falling light has a frequency equal to threshold frequency, electrons will be ejected but kinetic energy will be zero. But when frequency of falling light is more than threshold, then ejected electrons have kinetic energy and it goes up and up as falling light has greater energy. Alright, so these are some points which we have discussed, and this was firstly explained by the scientist we all know, are very famous, very well known, Einstein. And Einstein got Nobel Prize for explaining photoelectric effect. So this is it. We have explained everything. If you want to know the formula, we can talk it about. He gave a formula of photoelectric effect which was like this: this is the energy of incident light, and this is work function, and this is kinetic energy. What I have explained all here is it is given in a formula manner over here. Photoelectric effect is a reverse of X-ray emission, as you have already studied. All right, so this is it.